We're going to take a sample of 10 from a binomial distribution with p equals 0.5. Note p equals 0.5 means q is 0.5, so we're starting off with a binomial distribution that is symmetric to start with. Let's see if that has any benefit for us. Then we're going to divide by 10 to get the sample proportion because we're taking samples of 10. Let's take 100 such samples and look at the distribution of the means. Now this is actually relatively quick to do on the calculator. So what we're going to be using, going into the catalogue, is the rand bin just here. So what we put in here is 10, because each of our samples is going to be a size 10, 0.5 because that's the probability of success, and then after that we can put in 100 to tell it we want 100 such samples. And if we do that, you can see there's going to be 100 things across here. Now we're after sample proportion, so what we need to do actually is divide by 10, and this will just literally divide every single one of these by 10. It's not going to give us 0.6 and 0.3 straight away because it's going to give us another random sample, but you can see 0.7, 0.3, so you can see they're all divided, and now we have sample proportions. What I want to do is store those in a variable, and I'm going to use variable a. Now part of the reason that I did that was, if I go to statistics, I'd already set a up in an earlier thing that I recorded today in here, but to get this as a, all you do is, so for example I click on list 2 and just replace list 2 there with a, and then it would fill the values in. So that's already set up. Just make sure the graph is set up, and then clicking on here, I've got histogram and main A set up from an earlier example, otherwise you'd have to do that with the frequencies 1. And let's just click here. It tells us start at 0. I'm going to go with what they've suggested. Let's see what sort of picture that gives us, and you can see that's actually not bad. It's certainly better than the ones I've actually generated before for this same number. Let's go back and see what happens if we regenerate A. Might not be as good as that one. So it's changed, which means it will have changed here in statistics. And let's just go with what they've suggested. It's actually it's not that bad again. It's starting to look quite normal with the higher values here. It could be a bit more symmetric. Obviously a greater number of samples should give us an even better picture. Let's try that. Let's just go for 200. It might be too many for the calculator, I'm not sure. It may well be for your handheld. So it seems to have done it. Let's go back to statistics again. Let's just see if it's, yeah, we've got values all the way down here, down to 200. So let's generate and see what that gives us. Yeah, and it's really quite good now, isn't it? Now, the next thing that we're asked to try, I'm not going to do it, I'll leave this for you to do. Try repeating the experiment with p is 0.3 and then p is 0.1. So we're starting with distributions that are actually less symmetric to start with. Now, it may surprise you to learn that eventually even these very asymmetric distributions will start to look like the normal eventually, but I think we'll get less good pictures with the sort of numbers that we're taking with 100 samples and so on. So have a go at that and see if that works out.